Here's an example of solving a problem with resistors in series. So first of all, we're going to take the information and draw a circuit diagram. So you would draw your battery, let's say, and draw a resistor maybe on each side of a rectangle. So we could imagine that we'd have maybe the 10 ohm, 30, and the 60 is up here, but it doesn't matter the order. That doesn't change the math. Okay, for a series circuit, the way you find the equivalent resistance is to just add the resistances. So that's really easy. And what I mean by equivalent resistance is just the overall resistance of this particular circuit. So I get to just add the numbers. Okay, and if I do that, I just get 100. I do get to keep, 3 sig figs because the addition rule says I go by the decimal place, not by the total number of sig figs. And here we get, a sum of 100. And so to the nearest 1, I'm just putting a dot here because I'm saying that all of those digits are significant. Okay, the next question is the current through the resistors. Well, the current is the same everywhere. I could put, I could put an ammeter in here. I could put an ammeter in here. I would still get the same current because in a series circuit, there's only one way the current can go, and it's going to go through all of the resistors on its way to the other side of the battery. So I just only need to solve one time, and current total, which is the only kind there is here, is the voltage over the equivalent resistance for this circuit. So I have 3 volts divided by 100 ohms. So I'm going to get 0.03, but I want to put zeros after that so that I still have 3 sig figs here. Units for current are amps. Let's box this one too. Okay, then it wants to know the voltage drop across each resistor individually. What that means is, remember the potential energy of, let's say a proton, is gonna go down. So the battery boosts it up, pushes the positives where they don't want to be, gives them a lot of potential energy, and then kind of like, a water slide or a playground slide, this has 3 stages where the voltage is going to drop. The potential energy is going to drop, and it's going to get converted into kinetic and then to a little bit of thermal energy inside of each resistor. So it's going to lose the potential it had. And the rule here is that finding voltage in a series circuit, each voltage drop could be different. So the voltage drop across the 10 ohm, I'm just going to put a little subscript here to keep track, would be the current multiplied by that particular resistance. So for that one, I multiply my 0.0300 by 10. And then I know that the voltage is going to go down by 0.3 volts. Okay, but then I'm also supposed to find the other 2 voltage drops. Let me make a little more space here. Okay, then I just do that same thing, only for the 30 and the 60. So here's the voltage drop across the 30 ohm resistor. Oops, I only had 2 sig figs up here, so sorry about that. Let's Okay. So then here I should get 0.9. And then the last one should be the rest, because what I'm doing here is I boosted the potential by 3. Now it's going down by 0.3, down another 0.9, and then the rest of the voltage drop should be the difference between the total and those two, but let's solve it. Okay, so when you multiply here, we're keeping 2 sig figs 1.8 volts. Okay, and then the total drop across the 3 resistors, that's the last question. Really, we don't have to do any math because the voltage drop is equal to the voltage from the battery. Okay, it's also equal to the sum of all these. Okay, but you could just not do any math. But you could also add them all up just to make sure that they come out to the right sum. So here this was 0.3 plus 0.9 plus 1.8. Okay, so we do get 3. That checks out just fine.